Dear my student, let us proceed with the said properties or the said description of a wave. This is called frequency. You'll be asked to define what is the frequency is. Frequency is very simple. Frequency is very simple. Why it is simple? Because it's just the number of complete cycle in a second. How many cycles a wave make or a wave made in a second? Within a second, a wave can make, for example, can look this example here. A wave can make maybe, for example, this one here. Within a second, let us assume now this is a second we are talking about, 1 second. Within a second, a wave can make, this is a half, this is a half, this is a half, this is a half, this is a half. 1, this is 1, 2.5. Therefore, for example here, within a second, a wave made 2.5 cycles. Now, 2.5 cycles are what we call frequency. 2.5 cycles are what we call frequency. Therefore, frequency are the number of cycles a wave can make in a second. The number of cycles, the number of complete cycles a wave can make per second. This means how many cycles a wave completed per 1 second. How many cycles? Can be 2, can be 1, can be 6, can be 11, 20. It depends on the source. But within a what? Second. Not 2 seconds, not 1.5 seconds. Within 1 second. How many cycles are there? For example, in our example here, we have obtained 2.5 cycles. This is what we call frequency. This is what we call frequency. Therefore, the number of cycles the wave can make in a second. The number of cycles the wave can make in a second. Mathematically, we can come up with this one here. Mathematically, we can treat frequency as follows here. We can come up with an interesting idea here. Mathematical frequency, which is given by small letter f, is equal to number of cycles in 1 second. In 1 second. Number of cycles in 1 second. Now we are talking about 1 second. Sometimes you'll be given the time which is more than 1 second. Therefore, for more than 1 second, how can we calculate frequency if the time given is more than 1 second? It is simple. What you're going to do is then frequency will be equals to the number of cycles, let us assume to be n, you divide by what? The time taken, which is t. Therefore, for more than 1 second, frequency will be obtained by taking the number of cycles made divided by the time taken to make those number of cycles. Therefore, this is how we can calculate frequency mathematically if the time given is more than 1 second. Okay. Now, from this concept, you have an interesting idea here. Let me lab here. Before labbing, we have an interesting idea. Do you remember about time period? Yes. Time period was given as t, time taken of number of oscillation. The time taken to complete oscillation, this was called time period. You can give as Roman 1. But what we have here is frequency. Frequency is nothing but number of oscillation over time period. Can you see these two equations? Can you see these two equations? Here we have period is time taken of number of oscillations, but frequency is the number of oscillation of time taken. Do you see how these two concepts relate? These two concepts relate? Yes. From these two, we can conclude that thus it seems that period and frequency are inversely proportional. Therefore, thus period can be calculated by taking reciprocal frequency or period can be calculated by taking reciprocal frequency, or sometimes also frequency can be calculated by taking reciprocal of what? Period. This is what we should note as this is the relationship between time period and frequency. They are inversely proportional. You take reciprocal of another, you get the other. From there, we have the following to note. A frequency of a wave is a constant value. A frequency of a wave is a constant value. This is what we should note. A frequency of a wave is a constant value. Does not change with the change of the medium. The frequency of a wave does not change with the change of the medium. This is what we should note. And because now the frequency of a wave is not changing with the change of the medium, it is said to be a fundamental properties of a wave. You'll be asked to explain why a frequency of a wave is called a fundamental properties of a wave. The frequency of a wave is the fundamental property of a wave because it does not change with the change of media. For example, if a wave is moving from denser media to less denser media, the frequency will remain to be the same. If the wave is moving, for example, from air to water, if frequency here was 20, also at water will be what? 20. Why? Because frequency does not depend on the media, depends on the source. Frequency depends on the source. Frequency does not depend on the media, the wave it travels, but it depends from what is the disturbance from the source. Therefore, by saying so, frequency wave do not change. If does not change, it is now given another name. What is that? Fundamental. It is said to be a fundamental properties of a wave. If you do not understand, let us assume you take your arm, you move it from air to water. Take your arm, you move it from air to water. What will happen? What will happen to your arm? The speed of your arm will change, but could your arm shape change? No. Now we take your arm as a frequency, that air was one media, water was another media. The shape of the arm did not change, but the speed of your arm changes. That's why we are saying frequency of wave do not change. Do not change because it depends on the source. Another thing to note here as frequency concerned, frequency is denoted by the letter F, small letter f. But also its SI unit is cycles per second, because I said for you to calculate frequency, you take the number of cycles, you divide by the time taken. Therefore, in terms of SI unit, you take this is number of cycles, in cycles, time taken is in second. Therefore, SI unit of frequency is cycles per second. Now, sometimes cycles per second is called hertz. Therefore, the SI unit frequency is Hz, which represent Hz or cycles per second. Now let us go quick to examples which will help us to calculate frequency, to know how we can calculate frequency. Let us go quick. Time is rushing. If water waves oscillate up and down 3 times each second, what is its frequency? The question is saying water waves oscillate up and down 3 times. This means what is each what? Second. What is frequency? What is its frequency? Let us go to definition. Frequency is the number of cycle, is the number of complete cycle in 1 second. Now, how many cycles completed here? 3 cycles. Therefore, frequency here is equal to 3 cycles per what? Second. This example 1 was like that way. Or frequency equal to 3 Hz. The answer was 3 Hz as from that diagram. Another question is asking, example 2, find the frequency of the wave if 10 crest and 10 trough are produced in 2 seconds. 10 crest, 10 trough. If you produce 10 crest, the number of crest have been given, number of crest 10, number of trough is equal to 10, time taken is equal to 2 seconds. What does it mean? Means here, for us to get a full cycle, that means we must have 1 crest and 1 trough. That is a full cycle. For us to get a full cycle, we must have a what? Look here, we must have 1 crest and 1 trough. Now, having 10 crest and 10 trough, that means we have 10 cycles. That means we have what? 10 cycles. Therefore, here we can now frequency can be calculated as follows. Then frequency is equal to number of cycles of time taken. How many cycles do we have? 10 cycles. Time taken 2 seconds. What is the value of frequency? 5 Hz. This is how simple it is. Now let us go to the last example, which is example number 3. Example number 3 is given as you can see here. I think you can see it. This is peak to peak trough peak values. We have 0.01, 0.03, 0.05. You have been asked to determine the wave frequency from this diagram. Now, for you to determine frequency, we must have period. We must have period because this graph is displacement against period. Therefore, what we have here is period. Now, before getting to frequency, let us recall from how can we get frequency while we have period. Frequency is the reciprocal of period. But what is period? But according to our equation, period is equal to, look here, from this point to this point here, this gap here is what is period is. Now what is this value? 0.05 minus, therefore period is obtained by taking 0.005 minus 0.001. Therefore period is 0.004. This is period. Now what about frequency? Then frequency will be equal to reciprocal of 0.004. The answer here is 250 Hz. My students, that this is the end of today's presentation. I hope you have enjoyed and get different concepts. Next time we're going to see different other physical quantities which used to describe a wave. Bye.